Hey, Algebra 1. This is Mr. Harris coming at you from a little bit different angle. Gosh, that sounded so cringe. So cringe. But you're going to see today that we are going to be dealing with some Delta math here. This is our Chapter 1 wrap up. And so what you see on my screen are the four different concepts that you're going to kind of wrap up Chapter 1 with. A couple of these are maybe some things we haven't seen since early on in Chapter 1 that I wanted to review with you guys. One of them is from the middle of Chapter 1, word problems. These two middle sections here are all about word problems. And then this final section actually comes from the end of our chapter. And actually, these are the last three problems of our tests that we just took are based off these. So we've got sort of beginning, middle, and end. And I just wanted to run through a couple of these in each section just to give you guys an idea and a friendly reminder. And so let's start off with the very first one, words to expressions. So you're going to see down here in the corner, you have my webcam here. And if you want to see me kind of work these problems out, here is where that will happen, right here. So let's get to it, guys. Now we're going to represent, anytime you see the word a number, that means a variable that we don't know. We're going to call that x. So we're going to represent the following sentence as an algebraic expression. Ooh, now reminder, expression. That means no equal sign. An expression has no equal sign. So if we have 2 is being multiplied, okay, so I've got 2 times, and again, this is the first problem I'm working out here. 2 times, now it's being multiplied by the difference of a number and 4. Now that word difference, that's going to mean subtraction. So we're multiplying 2 by a subtraction problem. Well, how do we split off the subtraction problem so that we do it first before the multiplication? We use parentheses. So the difference of a number, which we call x, and 4. So 2 times parentheses x minus 4. Let's see if that's right. Aha, there you go. And if you need your explanation, there it is. Let's do one more together. How about one? There we go. Let's do this one. This one's a little bit different. Sorry, my light just kicked off. So 8 is going to be added to the square of a number. 8 is going to be added to. So in other words, we're going to be going down here. This is our second problem. We're going to be going, something's going to be having 8 added to it. We just don't know what yet. Well, what are we adding 8 to? The square of a number. So we know we're going to have x. Now what does it mean to square? Oh, that means to raise it to the second power. So x to the second power plus 8. And if you're not sure how to do that on your computer, you actually can hold down the shift and then press 6. So shift 6 at the top of the page. So there you go. That's how we get that. On to our next section, which is similar. We're going to write linear expressions from context. So let me back out of here. So I will scoot the page down, writing linear expressions from context. So this will be, I'll do one of these with you guys because really I think one is all it's going to take because all of these problems are going to be very similar. So Faith is driving to a concert and needs to pay for parking. There's an automatic fee, automatic. She's got to pay it no matter what, of $7. So 7, just enter the parking lot. Now when she leaves the lot, she will have to pay an additional $2 for every hour she stayed in the lot. Ooh, okay. So 7 plus 2 times. Now let's see what we're going to represent the number of hours. How much total money would Faith have to pay for parking if she left her car in the lot for 3 hours? How much would Faith have to pay if she left her car in the lot for T hours. Okay. So 7 plus T is going to represent the number of hours. So $2 times the number of hours. And what we have here is what's going to go down here in our general expression. So 7 plus 2T. Now they asked us something else in here too. They asked us, what if we stayed, or what if she stayed for 3 hours? Well, then we're going to take 3 and plug that in for T. So 7 plus 2 times 3. 2 times 3 is 6 plus 7. That would be $13. So we put in 13. Let's see if we are right. Aha! 2 for 2. Actually, I guess that's the first problem. Adding them all up, that's 3 for 3. Let's go. Okay. So only 2 sections left, guys. How about basic word problems based off percents? So there's going to be 2 kinds for this one. There's going to be a kind where you're trying to figure out what's left, and there's going to be a kind where you're trying to figure out how much you originally had. So let me split this up. 2 sections. The first one, sorry, I clicked on the wrong section here. Basic, there we go. So this first problem, how many toy cars does she keep on her wall? Now this is a how much is she actually keeping, not a how much does she have. We know how much she has. She has 300 toy cars. We're trying to figure out how much would 30% of those toy cars that she keeps on the wall be. So this is a how much left problem. But there is also a how much to start version. So there's a how much is left and a how much to start. Now let's do the how much is left, which is what we see on her screen. If she has 300 toy cars and she's keeping 30% of them, this is the easier one. This is just going to be multiplication. It's a multiplication problem. And what we're going to do is we're going to say, okay, 30%. If she had 300 cars, we're going to multiply that by 30%. But what would 30% be as a decimal? Well, you move the decimal 2 places. So move the decimal 2 places to the left, and really 30% is 0.30, or just 0.3. So we do 300 times 0.3, and that gives us 90. So she's got 90 cars on the wall. 90 cars on the wall. How about we do, after we get this one right, how about we do one where you actually have to figure out how much they had originally? That's going to be a little bit tougher. Yeah, we got it. All right. Let's see. So this one is going to be, about, it's kind of going to be what we're talking about, with dealing with part over total and percent over total. That's not exactly what I was looking for. Let's see. No, that's another one where you just multiply and see how much you have left. Here we go. So a group of friends were working on a student film. They spent $550 on props, which was 55% of their total budget. What was the actual total budget for the student film? So how much did they have to start? What was their total budget? Well, here's what we're going to do. We're going to have 2 fractions here. We're going to go with, it's going to be part over whole equals part over whole. So we know they spent $550 out of, we don't know how much the budget actually was. So this is $550 out of the total budget, which we don't know. How about percentage-wise? What's $550 a percentage? Well, they tell us that is, look back at our problem, they tell us $550 is 55%. So we can go 55% here over, how much is the budget the total budget percentage-wise? Oh, that's 100%. And what we can do is we can reduce this fraction over here. We know 55 over 100, if you do that, that reduces down to 11 out of 20. So we have, let me bring this over here, we have 550 over x equals 11 over 20. And if any of you guys know about a fraction equals a fraction, we can use what's called cross multiplication. Bust out some cross multiplication to say, okay, I'm going to multiply 550 times 20, and I'm going to multiply 11 times x. So 11 times x, you may have heard this called the butterfly method, which is an awful name. 11 times x is 11x equals 550 times 20 is, oh gosh, 11,000. And so how do we solve? We divide by 11, and you end up with the budget being, the budget was was $1,000. So there you go. Those are the two different kinds of examples there. And then I will do just one problem with you guys on one variable equations. Let me just fix the camera real quick. I'll do one example with you on one variable equations. Let's back out. Okay, let's look at the one we have on screen here. We've got negative, parentheses, 6x minus 2. And again, guys, always write this out. Write it out. That's a terrible way to write. Write it out. Equals, we got a negative there, 6x minus 3. Remember, we want to distribute. We distribute that negative. So that gives you negative, let me do this in a darker color so you guys can see better. Negative 6x, negative times a negative 2 is a positive 2, equals negative times 6x is negative 6x. Negative times negative 3 is positive 3. And guys, look at this. Same variable with the same number, but a different regular number. Watch what happens. We add 6 over. That cancels. That cancels. You're left with 2 equals 3. But that's not true. That's because the left side will never equal the right side. No way. And so this is a no solution. And so hopefully that helped you guys. Hopefully you see what we saw here. If you have any questions, you guys know how to let me know. But let's get chapter 1 wrapped up in the best way we can. Thank you.